Okay, so we are in section 8.7 talking about Taylor and Maclaurin series. And Taylor and Maclaurin series, as you know, there's a table in the book in section 8.7 that gives Maclaurin series. In your course content in Blackboard under the section 8.7, there is a handout that I prepared that has all of like some very important Maclaurin series formulas. We did some great, nice examples in our last class from section 8.7. I want to do one more with you. Let me give you a moment to copy this example down. Okay, so in this problem, we want to find the Maclaurin series for this function. The function is e to the 2x power times the log of 1 plus x squared. And, you know, if we were to try to find a Maclaurin series from like scratch, where we have to, you know, find the derivatives, the first, second, third derivatives for this function, it could get a little messy. Okay. So what we're going to do is we're gonna based on the table of Maclaurin series, we're gonna write down the Maclaurin series for e to the 2x power, and then we're going to write down the Maclaurin series for the log of 1 plus x squared. Okay, and we're going to make use of those Maclaurin series then to help us get the power series for this function. Okay, so when we do this here, if we go to the next page, is everybody good on this? Everybody has it copied okay? This example? Okay. Thank you, everybody. Okay, great. Well, so here is that handout, a copy of the handout, and you can zoom on the right, click your zoom button on the right if you want to blow this up a little bit. And of course, the handout has the Taylor series formula. Okay, and then it has Maclaurin series with intervals of convergence. And then at the bottom, it has what's called Taylor's inequality. And we're going to talk about that in section 8.8. Taylor's inequality we'll get into that. So for this problem, Who can circle the two series that I'm going to need to use here in this problem? Who can circle the two Maclaurin series that I'm going to need to use? Okay, Renat. Yep, you can take the pen up there. Okay, there's one of them. Good. And there's the other. Okay. So if we know the Maclaurin series for e to the x, we can get the Maclaurin series for e to the 2x power, right? It's like e to the apple. And if we know the Maclaurin series for log of 1 plus x, we can get the Maclaurin series for the log of 1 plus x squared. Okay, so let me just see here. One moment, class. Yeah. All right. Let's go to the next page. Okay, so what I do is well, let me just, maybe I can add a little bit to this. So in our solution, one moment. Hold on. One moment, class. Sorry, back here. All right, so okay, so there's the power series for e to the 2x. Okay, and what I've done is I've written out the first four terms of that Maclaurin series. Now for the log of 1 plus x squared, that's the power series. Starts at n equals 1. Okay, and negative 1. Negative 1 to the, hold on. Negative 1 to the n minus 1 power times x squared to the nth all over n. That comes from the table. You'll have access to that table on your final exam, of course. That table and section, well, my handout it includes the table, so section 8.7. So, okay, are there, and then here I've listed out some terms of that second series. Are there any questions on, and you know, I'm multiplying the one series by the first series for e to the 2x. I'm multiplying that series by the second series for the log of 1 plus x squared. Are there any questions on that first step? All right. Well, now what do we do? What do we do? And why did I write the terms out? Well, it's because in this problem, we're being asked to find specifically the first three non-zero terms in the Maclaurin series. Well, if I, and what am I doing here? I'm taking a Maclaurin series for e to the 2x and multiplying it by a Maclaurin series for the log of 1 plus x squared, so I can get a Maclaurin series for the function e to the 2x times the log of 1 plus x squared. That's what I'm doing. But I only need the first three non-zero terms. So I have to enumerate out the series. And now, well, in this second step, what I do is, of course, I simplify the series a little bit. So, the first series has these factorials below, and we know 1 factorial equals 1, 2 factorials 2, 3 factorials 6. And then, we're in the numerator, we have 2x squared, 2x cubed. So I just I simplify things for that first series, simplify the terms, and now I'm taking this first series times the second series. So the way you want to think about this is the best way to think about this is the following. I'll do an example here. Let me just do a kind of a little example. Let's say you have 1 plus x times 2 minus 3x. Let's just say it's an example. Now you've learned, hey, to multiply 1 plus 2x times 2 minus 3x here, you've learned to do FOIL, right? The FOIL technique is first, outer, inner, last. But it isn't the only way to do it. You could keep 2 minus 3x, like leave it right there. And then you could distribute the 1 and distribute the x on the 2 minus 3x. And if you did that, that would get you 1 times 2 minus 3x plus x times 2 minus 3x, right? And that would get you 2 minus 3x plus 2x minus 3x squared. Okay, and that'll get you 2 minus x minus 3x squared. Let me just see one moment here. Yeah, that's right. So I didn't do FOIL there. What I did was I first of all distributed, like for this first binomial, I distributed the 1 times the entire binomial in the second parentheses, and then I next took the x from the first binomial and multiplied that by the entire second binomial. We can do the same here, same idea here. When we multiply these two power series, okay, this power series and this power series, I can take the 1. Well, I can treat this entire second series as, like, just leave it there, and I'm going to multiply 1 times that series plus 2 times that series plus 2x squared times that series, and so forth. That's a legitimate way to multiply one power series by another power series. Now, when we do this, we want the first three terms. So I know that, well, 1 times x squared is going to give me, 1 times x squared. And then, so, I'm looking here at the 1. And I'm looking at 1 times x squared is 1 times x squared. Then 1 times negative x to the 4th over 2, that's here. Okay. But I don't go any further. I don't go any further. I don't take 1 and multiply it, for instance, by x to the 6 over 3. Why is that? Why don't I keep going? Why do I stop? I mean, I can keep going. That's what the plus with the dot, dot, dot means here. I can keep going, but I choose not to like write out any more terms for the product of 1 and the second series. Why is that? What do you think that is? Think about that. Think about that for a moment. Think about that for a moment. Let's now look at the 2x. We're going to take the 2x and multiply it by the entire, term by term on the entire second series. And I go, all right, I go 2x times x squared. And then, oh my gosh, I stop. I mean, I have a plus dot, dot, dot. I know it keeps going, but I don't write any more terms down. Why is that? Why don't I do this? Why don't I have here 2x times negative x to the 4th over 2? Hold on. Okay, why don't I do that? That's right, Renat. I'll get more terms than what's asked for. What's the highest order for the first 3 terms? What's the largest degree for the first 3 terms? What's the largest degree I'll need? That's right. That's right, Renat. Degree 4. So I'm wasting my time taking 2x times negative x to the 4th over 2. I mean, what I'm saying is I don't need that. That's what I'm saying, because the first 3 terms, the third term is going to be of degree 4. The first term is going to be of 2nd degree, and the third term is going to be of 3rd degree. Now notice I need to gather together all terms that are of 2nd degree, 3rd degree, or 4th degree. And to that end, oh, well, I do have a 2x squared here. Okay. And if I take a 2x squared and multiply it by x squared, that is going to get me an x to the 4th term. Okay. And then I stop there. And so now I have my first 3 terms. So a student asked me this at office hours a few days ago, this problem. I hope this is helping the student. Maybe the student can give me a thumbs up if they're comfortable now with this problem. But 2x times x squared gets me 2x cubed. 2x squared times x squared, that's going to get me 2x to the 4th. But then I have this minus x to the 4th over 2 here, so I subtract. Okay, thank you, Nathan. Now I subtract minus x to the 4th over 2. Hold on here. Okay, and if I combine those 2 terms, I'll get 3/2 x to the 4th. And then, of course, the x squared term comes from just 1 times x squared. You see how that works, class? Who's comfortable with that? And by the way, in WebAssign then, in WebAssign, what you would enter would be this answer here, the first three terms. Okay, give me a thumbs up if you're okay with that. Give me a thumbs up. Okay, Tall's good, Jazi's good. Renat and Marcus, good. Leping, how are you with that? Are you good with that?
No, I didn't get the last term. How could you get the 3/2x to the fourth power?
Oh, okay, okay. So do you see here? Do you see here how I, in purple, I circled this term here and this term here? You see me circling those terms on the screen?
Yes.
Okay, and those are, I'm circling, those are my x to the fourth terms. Well, 1 times negative x to the fourth over 2 is equal to negative x to the fourth over 2, right? And write that a little bit nicer here, right? And then the 2x squared times x squared is 2x to the fourth. So it's 2x to the fourth minus x to the fourth over 2, right? That's just going to equal 4x to the fourth over 2 minus x to the fourth over 2, and that gets you 3/2 x to the fourth. That's how we get the 3/2 x to the fourth here. Okay, is that Marcus, question?
Yeah, so I guess my question, like, I understand how you got that, but if that's the case, why didn't you just also do it with the other two, like 2x squared, um, or 2x times x squared plus, and then why didn't you include the 2x times negative x to the fourth? Do you get what I'm saying?
Okay, good question. Let's say I did that. Let's say I included for the 2x squared there. Oh, hold on. I'll go down. Let me go down. Right. You're saying like 2x squared times.
Yeah, I'm saying, like, why didn't you do it for the other ones you added also then?
Okay. Let me ask you this. What's the degree of this monomial? 2x squared times negative x to the fourth over 2. What's
X
the
to the
power
6.
of x going to be? Sorry?
X to the 6.
Yes. But that would be part of the fourth term then. My first three terms have powers x squared, x cubed, and x to the fourth. So if they asked, for instance, for the first four terms, then I would need to like include that along with some other things. But I don't include it because I don't need it. If I just want to list out the first three terms, I only need x squared term, x squared, x cubed, x fourth. The 2x squared times negative x to the fourth over 2 would give me x to the sixth power. It'll be negative x to the sixth, right? But that's going to be then like the fourth term, and I only need the first three. Does that help? Help you see it?
Sort of.
So you agree that the next term here, like you're comfortable that I have the first three terms here, right? In other words, think of it like this. Think of it like this. I think I can approach this another way. So you're thinking, well, Dr. Judy, how do I know that x squared is the first, that there's no other x squared contribution in terms of the terms. When I multiply the power series by the other power series, how do I know there's no other x squared term? Okay, it's because if you multiply, if you continue doing multiplying, the only way you're going to get an x squared term is by taking 1 times x squared, okay, and by taking, well, that's the only way to get an x squared term. Now, how are we going to get the x to the 4x to the x cubed terms? I'm going to take 2x times x squared. That's the only x cubed term I'm going to get. That's the only one. And then for the x to the 4th term, the only way I'm going to get an x to the 4th term is by taking 1 times negative x to the 4th over 2, and by taking 2x squared and multiplying it by x squared. There's no other like multiplications that are going to give me terms that are like x to the 4th power.
Okay, I think that helped.
All right, good. And also, we can do this with division of power series also. We can do this for division of power series also. They do example 13 in your textbook, where they have a part A and a part B, and they actually find the Maclaurin series for the tangent of x by taking one power series and dividing it by another power series. So I'll let you look at example 13, part B. And I believe in your web assign there's like a watch it video for that also. But are there any questions before we move on? Yes, Nathan.
So my question is about, I guess, Maclaurin series that are similar to these references that you gave us.
Well, the tables like this, these are Maclaurin series.
Yeah.
These are Maclaurin series, yes.
So on our homework, we're not likely to, or maybe the exam, whatever, we're not likely to see an exact version, right? So we had the natural log of 1 plus x squared as opposed to 1 plus x. So correct. I just want to make sure I understand the substitution aspect of that, like the transformation, I guess, of the series.
Yeah, well, it's like let me see here, one moment. So the like you said, I'll try to write over here. Like you said, the log of 1 plus x is, hold on, I'm going to get to the table myself. The log of 1 plus x is this series. Okay, and let's not worry about the interval convergence right now. Now this means then that the log of 1 plus an apple, here I bring in the apple again, that would have to be this series, right? Is that so far so good, Nathan?
Yes.
All right. Well, therefore, the log of 1 plus x squared has to be then, that's the x squared is my apple. That's the apple. And so
Yeah, I think I definitely see what we did and how we got, I guess, the terms that you wrote down. I just want to make sure that that is like a consistent strategy for,
Oh,
say,
yes.
other series.
That is consistent. But what happens is sometimes, like in your homework, you'll be presented, they'll say, find the Taylor series for this function, and the function won't be there. It won't be there in the table. It won't be there in the table in section 8.7. It won't be, it won't be, it won't be, it won't be like in this list. It won't be in this list here. Okay. I saw a movie, actually, reminds me, I saw a movie about Stalin. You know, he was the communist leader of Soviet Union, a long time ago, right? But he had like lists, and if you're on the list, you're in trouble, right? That's what this movie is. Like, oh my gosh, I'm on the list, you know. But you're not in trouble if you're on the list here. It's good to be on the list. So if you have a function that you can relate to one of these power series on the list, you can take advantage of that. But in sections 8.7 and 8.8, you'll have some functions where they're not on the list. Okay, like for instance, if you had something like, if you had a function like this, say you had a function like say you had a function like hold on, let me just like x to the negative third power. Okay, let's say you had a function like that. Well, and you wanted to find a Maclaurin series for this function. You're going to have to work it out by hand. You're going to have to, you're going to have to utilize the formula here and find enough derivatives of the function. Again, the function, my example was f of x equals x to the negative third. This function, none of these Maclaurin series is going to help me with that one. For that, I have to actually derive the Maclaurin series. Okay, and of course, Maclaurin series A equals 0, right? But I'd have to basically find terms of the Maclaurin series, figure out the pattern, and get my series that way, like I showed in the last class. So you'll have a combination of different problems. You'll have a mixture of different problems, and some you can help. The table will help you. Others you have to derive the Maclaurin series or Taylor series. Okay, so all right, excellent. On that note, class, I'll stop the recording on this here.